hi everyone, my name's Chris Blackwell, and today I'm going to be mostly talking about application security. Before I get started, I just want to try and read the room. So, do we have any students in the room? Computer science? Yeah. Okay. What about cyber security? No? Okay. Do we have anybody who's a developer? Yeah, a couple of developers. Brilliant. Okay. Does anybody work in IT ops or DevSecOps? No? Okay. Hands up if you work in cybersecurity, or does anybody else work in financial services? Yeah, okay, brilliant. So hopefully we'll get some good things out of this talk. Today I'm not going to give a technical deep dive, but I do assume some technical background knowledge, nature of the talk. Okay, so let's get started then. So let me introduce myself. My name's Chris Blackwell, and I used to be a lead application security architect, but I've recently moved to the global security team, and I'm now a SecOps engineer. But I joined iPipeline in 2016, writing C#, .NET applications, API, and API security, and became a security champion. We moved into AWS, and I started AWS training, became an AWS security specialist, and then started working through the CompTIA training. I'm also a BCS committee member and the OWASP member as well, and we meet up in Bristol every once in a while. I've recently passed a CISSP exam before Christmas, so hopefully I've got some great things to share in this presentation. So as a lead application security architect, basically just a security architect, what I used to do was I used to create architecture designs, reviews and reports, and I used to support projects and the sprint teams. I also used to help facilitate the annual pen test. I've been securing our pipeline applications for over half a decade. As an OWASP member and a BCS committee member, I'm passionate about technology and security, mostly focusing on API security and the best practices to keep our applications and data secure in financial services. So when people say they work in cyber, what do they actually mean? There are many different areas of cybersecurity, so let me just give a quick brief overview so everybody can follow along. Okay, so I know this is a busy slide. Don't worry if you can't read it. I'm just going to quickly take you through it. So traditionally, there were the bad guys, the hackers, and the good guys, the IT system administrators. And these are commonly known as red team versus the blue team. So every year, the bad actors, they get stronger and their hacking tools get better. And our software and systems get older and more CVEs are discovered. So it's a constant game of cat and mouse trying to keep up to date. The hackers try harder to exploit our CVEs, and we've got to try harder to try and close the door on them. So it's important to keep our skills up to date with security certification to help validate our skills. And this diagram tries to highlight the different certifications available in each area of cybersecurity. So if I just quickly talk about the slide, if I start on the left-hand side of the slide, you've got communication and network security. You've got IAM, identity and access management, who the people are and what they can do. You've got security architecture and engineering, designing and building stuff. You've got asset security. So there's physical assets like stuff in the data center and digital assets like people's digital identity and the data that pipes through your system. You've got like tangible assets and intangible assets, stuff like your company reputation. There's also a lot of security and risk management. Regardless of which area of security you work in, you're going to get security reports and security findings that you have to manage and you have to prioritize. So security assessment and testing, you want to test that your systems are secure, and there's a whole different variety of skills in that area. Today, I'm going to be talking about software security, which is just this little thin blue slice of the puzzle here. We've also got security operations, so that's SecOps, blue team defending, and penetration testing, red team offensive security. But there's a lot of, as you can see from the diagram, there's a lot of different skills and there's a lot of different certification in this space, so it's hard to know where to start. Okay, so the main thing I'm trying to highlight in this is that cybersecurity is a broad area with lots of overlap. Blue team defends, red team attacks. Today I'm focusing on software security, AppSec, that little blue slice. So where's the best place to start with cybersecurity certification? I'd recommend starting with CompTIA. First, we need to understand the hardware, the hosting environment, and the network security controls that host our applications. Then we can layer on the understanding of cybersecurity, and this is SecOps. So maybe you're already studying at uni, and if you would like, it would be really easy to obtain certification in this area. If you're already studying it, it'll help you stand out amongst the crowd while going for interviews. So this can also help graduates and professionals already working in the field If you can get work to support and pay for your exams, CompTIA certifications can help boost your profile and give you something to talk about in that end of year performance review, help contribute towards your salary reviews and your pay rise. So when it comes to asking for a pay rise, some companies might use a benchmark. IT professionals with X certification and an average salary of X. So if nothing else, it just helps keep your skills up to date. I graduated in 2011 and went through CompTIA during lockdown in 2020 just to brush up my skills because they were like 10 years out of date and the networking stuff had sort of changed. Okay, so next I recommend putting it into action and building out a home lab. This takes time, but it's a great way to get hands-on and learn by doing, turning that knowledge into experience. So I started at university with just a laptop because I had to be portable. Then I got a small little notebook, which was cheaper, smaller, and easier to make notes at university, but it wasn't the most powerful. Then I bought a more powerful desktop, and then I could run VirtualBox, and I could play around with virtual machines. I needed a file server to back up my work and my VMs, so I got a cheap PC, installed Windows Server, and added a few hard drives. The Windows Server turned into a network server with network shares, FTP, IIS, hosting my projects and websites. And then I scaled up to get a second PC, installed Active Directory, and build out your network. But these days, you don't really need all of that. Most of my home lab these days just runs on one PC. I've got an old Core i7 machine with a few SSDs in it and 32 gig of RAM, and that's fine for running two virtual machines side by side. So that's all you need to be able to run Kali Linux against a target, something like Metasploitable or a Windows OS or Windows Server. Before you know it, you can start experimenting with other OS security tools like Parrot OS, pfSense firewalls, and other Windows operating systems. You can even go as far as installing Kali Purple and building out an open source theme with Docker. There's just a whole load of stuff you can do there. So for security and information and event management systems, just to get hands-on and get experience with the tools and techniques that you'll use in a security role. So another option is AWS. You don't need to buy your own hardware anymore. You can run stuff in the cloud. And the AWS free tier is free for a year. So you can just get in, start spinning up resources and start playing about. Think carefully about the resources you're spinning up and power down cleanly when you're done to keep costs low. AWS make it really easy to spin up a server in EC2 just to test something out, and then you just clean it up once you're done. You can use the Amazon machine image to start a VM in the cloud with Kali or Windows pre-installed just to remove that barrier of entry, make things faster. The main benefit is that it keeps the security tools, the activities, away from the company network and away from your home network because you're just playing in the cloud. You can be safe that you won't trip any alarms or burn out your own hardware. These days, a home electricity bill can soon start to add up, especially if you're running like rack servers and stuff at home. So AWS lets you test all of these fundamental concepts in a cloud environment. And at the end of the day, the cloud is just somebody else's server. It's just servers running in a network. So server security and network security concepts still apply to a virtual private cloud. Again, AWS certification is highly sought after skill that can help boost your career and help you keep your skills up to date and keep the cloud safe. So next I want to choose Identity and Access Management, IAM. So how do the users log into those services, and how do IT engineers log in to maintain those systems? And don't forget about those service accounts that interact with those server resources. So AAA security, authentication, who they are, authorization, what they can do, and auditing, record what they've done. The basics of user control. Okta is an identity provider that helps manage the users. And we can create an Okta dev account for free or use Auth0 to start to play around with access control. We can test users and manage their access to applications. We can host an API in our lab or in AWS, and we can use OAuth as Auth0 to get hands-on with those different OAuth flows and the bearer tokens. We can investigate other identity providers such as Ping Identity, Ping Federate for those SAML OIDC type integrations. So ISC2 stands for International Information Systems Security Certification Consortium. Yeah, it's a massive mouthful. But they also offer industry-recognized expert-level certification in the main areas of cybersecurity. Whatever your training path you may choose to take, I recommend following this approach. A structured learning path will help you to develop your skills towards a specific goal. You don't have to go for the exam at the end of the learning path. You could just follow the structured learning and learn the subject content. Study the exam and set your own exam timetable, a study timetable that works for you, and reassess as you go. You could just be lean and you could just learn enough for now. Maybe your goal is to recap on a basic understanding while working towards an internal business project. If you are thinking about going for an exam, talk to people about it. Work may pay for it, and other colleagues might know about it or already have done it. Websites like Test Prep Training and Whiz Labs offer mock exams to help reinforce your knowledge. And I'm simply trying to just explain all this to try and champion security, remove barriers to entry, and help bring more experts into the field. So how does all this map to everyday security activities? All that training should add up to help you build a picture of the security landscape. And there are many tools and techniques to learn to get hands-on with cybersecurity. So there's such a wide variety of tools that security experts can use in their security tool chain. And this heat map tries to help us map those tools and the functions that they perform. It's really helpful to identify the blind spots or the areas where more effort and funding is required. So if I quickly talk through this diagram, you've got users in the middle. These can be external users using your software. These can be internal users maintaining your systems. But you've got users on devices, and they can be interacting with software as a service hosted in the cloud, or they can be interacting with the on-prem applications in your hybrid data center. So you need to keep the end user safe with identity management, encrypting their machine, host firewalls, endpoint detection and response. You also have a lot of data going through, so you need cloud access security brokers to give you protection into those AWS type systems. And there's a whole lot of different security tools that help keep your data center safe as well. But it all comes down to this data protection, this data that's flowing through your devices and through your software. So you need to keep those logs and know exactly what's happening. And you need to pump all those logs into the Security Operations Center, the SOC, so they can be aware of what's going on, which parts of their network as the data flows through the system. You might even have IoT devices like industrial control systems, SCADA type networks. So there's a lot of different tools that keep your landscape safe. And it's important to know where those gaps are to try and make your security as safe as possible. Next, I want to introduce the CISA Zero Trust model. So this is the CISA Zero Trust model V2 from the Cybersecurity and Infrastructure Security Agency, CISA. And it helps us to protect our applications and our devices with process maturity, because we can identify where we currently are and where we want to be. We can identify a strategy and a roadmap to get the right tools in place with the right processes to improve the following areas. So if I talk about this, you've got identity access management, you've got devices, networks, applications, and like I said, the data that flows through it. And there's different levels of maturity, like traditional, people just doing stuff. Initial, you've got some managed process. More advanced, you've got different tools in place. And then optimal, you're optimizing against best practices. Okay, so that covers off my journey so far, and that's enough about SecOps for now. I hope people have found this section of the presentation useful. Now let's move on to the rest of the presentation. Assuming our hosting environment is secure, let's look at how we can build and host secure applications. Let's look at AppSec and the kind of applications we need to build securely. Okay, so at iPipeline, we sell life insurance. We collect data and we pipe it through our APIs to generate life insurance quotes, sort of like go compare or compare the market with life insurance. So financial advisors will use our portal and they'll input customer data, and we pipe that data to the insurance providers, and these are the big banks. And then we aggregate the results and give lots of different insurance quotes. So there's lots of sensitive data flowing through our systems. There's GDPR that we have to think about, personal identifiable information, personal health information. So in this talk, we're going to look at the best practices when building and deploying financial applications that process highly sensitive data. We want to bake security into our build and deploy processes to ensure a secure software lifecycle. I'm going to run through the SDLC and the different stages of the software development lifecycle and how to layer on security at every stage. Okay, so this is the standard SDLC flow, software development lifecycle. From project conception to delivery, and then continual support and maintenance, we need to think about how we add security best practices into every stage, and how to create and cultivate a security mindset. It needs to be part of BAU, business as usual, and definition of done. We need to identify the data classification, the security requirements, join analysis at a high level, that's the GDPR, PII, PHI. We need to build the security into the system architecture during the design phase. We need the SDLC security gates as part of our iterative development cycle, and that includes the security testing during build, QA, and deployment. Once it's deployed and delivered, we need security monitoring and alerting. Finally, we need that ongoing maintenance and security updates. So let's look at how we can integrate security into those 6 steps in more detail. Okay, so once we know what we want to build, the design's been reviewed, approved, and documented, it's time to start to build the new software as we enter the development stage. We might need to build a few microsites, a few external APIs, backend for front-end pattern, a few different domain APIs, microservices. It's important to build security into our processes along the way. So we'll start with refinement. Starting with story refinement and requirements gathering, we can identify all the security requirements. We can use threat modeling methodologies like Trike and Stride to identify abuse cases and test criteria. The team will do an API design workshop to document the spec for the API endpoint, and that's where they'll map out the request object and the response models. These are the data assets that need appropriate security controls covered by the scenario testing. To verify that the access control logic, that authentication, authorization, and auditing, basically, we need to identify the input parameters that can be manipulated and ensure that the API has the right checks in place. Next, development. We need to build a secure SDLC pipeline for each application. The SDLC needs built-in security with fast feedback for developers. We can make a pull request, run some security scans, rapid scans before merging, and then on merging to master, we can run an in-depth scan against the next release candidate. If the scan finds anything in master, we can either revert the change or roll forward with a fix. Security testing. Once our release candidate is ready for deployment, we can aggregate the security scan results into our release management tool. Maybe many stories make up an epic or a feature, and we can evaluate the security controls are correctly implemented. The iterative architecture review has a security pillar, and I'll produce a security report and feedback to the team. I try to catch all the security issues before the annual pen test to try shift left and remediate any of the security issues before it goes out the door and goes live. So we need to test out our SDLC, and we can do that with like a simple Hello World application. So the pen test, once the project's been deployed and released, and we've got the external annual security pen test for compliance. So we'll resolve any issues identified as part of ongoing maintenance, and the business will also define a roadmap for features delivery and richer user experience. So that's it at a high level. Now let's take a deeper dive into each stage. So let's look at the first stage, analysis. Does this need security? So the first stage is the analysis phase, and the business has decided to start a new venture and want to build a new system with the aim of offering a new capability to their end users. Let's say they approach this with a lean mentality, and the MVP, the minimal viable product, maybe that went well and the A/B testing was positive. The hypothesis has been proven and it's time to productionize the idea. I would say that there might be some security requirements defined here, but only at a high level. Okay, next is the business feasibility. The business might test the water with a lean MVP before committing to a large project. The project managers might map out the project into different milestones and phases. They might consult with the enterprise architects to get a high-level understanding on what's involved to bring their idea to life. This will mostly be at a high level and try not to overanalyze. We want to be agile and not waterfall. Data classification. The basic high-level security requirements will be discovered at this phase, and what kind of data might we need to capture? What kind of data is flowing through our system? And that brings us on to compliance and regulations. What kind of regulations might apply? GDPR, HIPAA, PCI DSS? We're selling life insurance, so there's a lot of different types of data. We need to have any data retention requirements mapped out here as well. So data sovereignty laws, we might want to host this new service in a multi-region for multi-availability. And do any regional laws apply? What's the big idea here, and how well does it scale? So iPipeline is a US-owned company, and could this product start in Europe, but also bring value to the US, in which case you've got data sovereignty and multi-region to think about. So let's look at the next step, the design phase. Does this need security? As we enter the design phase, the architecture team will start to flush out the designs. We might want to build a new micro website with a new form and a new API. We'll use domain-driven design. The form captures a new business object or the model. This is the new data asset that needs protecting as the data flows through our systems. So let's gather some security requirements and build security into the design. Okay, so security architecture. The first step in the design phase is for the architect team to get together and come up with a secure design. So let's start with a high-level API design, mapping out that interface of the API with the appropriate security controls. The data might flow through multiple APIs in a microservice type architecture, and it might have many different touch points. So for that, we need defense in depth. We need to implement a layered defense with continuous authentication. Each API needs authentication, authorization, and auditing, those different OAuth flows. So it needs to be secure by design with appropriate security controls for the data being processed. And we may need to apply this to a microservice architecture with security at each layer. We can design a zero trust environment with isolation and segmentation. We can use OAuth 2 with scopes and claims to decide what this API can do, what actions they can perform. So the attack surface. As the new data asset moves through our system, we need to identify potential threats and attack vectors. Given the classification of the sensitive data and the blast radius of change, we need to assess the threat landscape. We need to keep track of the areas of change and build appropriate defense into our attack surface. The new APIs need authentication and authorization checks using OAuth, OIDC, scopes, and claims. We could do this using federated access through single sign-on with external identity providers. And the new API endpoints need protection from the OWASP API top 10, most common vulnerabilities. And that's what we need to scan for. The new data assets need adequate encryption and access controls to conform with GDPR. So that brings us on to the MITRE ATT&CK and MITRE DEFEND. So as we design the new system components and the hosting solutions, we can reference the MITRE ATT&CK and the MITRE DEFEND framework. MITRE ATT&CK, adversarial tactic, techniques, and common knowledge. And we can also look to block them using the MITRE DEFEND framework. So let's say our new system needs a file upload for medical documents. MITRE ATT&CK would explain how an APT hacker group could exploit a file upload as part of the cyber kill chain. And the MITRE DEFEND would explain best practices to quarantine and sanitize the uploaded file and scan for malicious payloads. And this brings us into secure by design. So all this should be baked into the design and the definition of done. Never try to separate out security stories or layer on security at the end of a project. Okay, so next, let's look at the next stage, development. Does this need security? Yes, absolutely. So as we enter the development stage with the architect team, we'll start to guide the team with the implementation, and we'll do any run ahead work, and we'll explore any areas of unknown. We want to deliver reusable patterns. The sprint team should know exactly what's being asked of them and have the best practice example to follow. The architect team need to show the sprint team exactly what good looks like, and this includes the security. If we're asking the project team to do something for the first time, then we'll lean in and we'll give guidance. Firstly, we need to build that delivery pipeline. So as the team start with development, they need to know how to deliver secure code. So we'll start with secure coding standards. They'll build the feature abiding by our secure coding standards. We also have coding standards for best practices like clean code, object-oriented programming, solid, and so on. We have the internal documentation outlining the best practices for building APIs. And it'll have stuff like OAuth documentation outlining the different flows versus when to use API keys. Best practices on how to handle application secrets, encrypted variables, secret stores, and secure coding. So how to protect our APIs from the OWASP top 10, as well as the OWASP API top 10, and also building things like redundancy and rate limiting. Client-side security is important to protect against things like cross-site scripting and cross-site request forgery, but any client-side validation can be manipulated and circumvented. So we need to lock that down with the API, and we need to enforce the security checks server-side. Do that with secure defaults. So we make this bit easy for the team by providing reusable code libraries. We have a collection of in-house NuGet packages and NPM libraries that have secure defaults for doing things like secure deserialization, stuff like that. There are common helpful functions for security-related functionality built in a reusable way. So we can do things like encryption, deserialization, and just those common operations. So it's a consistent approach across all our applications. And this makes it in a way which is secure from the OWASP top 10, because we've got the security built into those reusable code blocks that are reused against all our applications. So next we have IT integrations, IDE integrations. The development team can also use an IDE plugin, things like ReSharper or AWS Code Whisperer. And these can be great tools that increase productivity as well as offering security recommendations. And we need to test our access control logic. We also need to test our work, so patterns like test-driven development, behavior-driven development can ensure that software works as intended. The developers must create a unit test as part of definition of done, and we need to build integration tests as well as automation tests to make sure that we haven't broken anything and that the UI design works as expected. The test pyramid helps to get us the right balance of testing in the right areas. The main thing is we need to think about how we're going to test the access control logic, including session lifecycle, like session creation, termination, and session timeout. We want to test the things like session validation to protect against session manipulation. So sometimes this can be challenging. So manual tests can outline the test steps using a given when then type syntax. The testing stage will cover this in more detail as we hand over to QA. So when the code's ready, we'll create a pull request. And we'll open the PR and conduct a code review, following our PR template and the code review guide. We can reference the OWASP developer guide and the OWASP secure code review. We can run security scans using GitHub actions that trigger on a pull request. And we can escalate the pull request if we need a technical review or a security review as part of the iterative architecture review process. So there's a way to escalate for the code to be reviewed at a higher level if you need to, depending on what kind of data you're processing and what kind of operations or complexity you're facing. So training. The aim of the code review is to catch all the little simple mistakes. We're only human. We don't know what we don't know. And sometimes a second pair of eyes can identify a better way to do something. Sometimes it just comes down to knowledge and experience, and we can help each other grow. The architects can give examples to the developers, showcasing what good looks like. We also have a security champion program, offering more learning about things like checkmarks, code bashing, and other code security best practices. We have on-demand training resources from things like LinkedIn Learning and Pluralsight. These are great places to learn by doing and get those code examples to sort of play about with example code. There's also a lot of formal training as well, so we can do things like the CompTIA cybersecurity path. We want to write good, clean, secure code and give people the tools to do just that. Okay, now let's look at the next step, testing. Does this need security? Yes, our SDLC definitely needs automated security testing. We need to run tests as part of the pull request. We need to run security scans on the code on a schedule, as well as part of our pipeline. There might be a microservice that doesn't fall into a project footprint, and they still need those automated security scans. Even without any code changes, the security tools can get a definitions update that identifies new vulnerabilities. And we need to pull those results together and scan in depth as we move through our environments. So security scanning, it's a big part of the SDLC. We need CI/CD integration for continuous integration, continuous deployment. We need to integrate security testing into that pipeline. We need security scans that cover the OWASP top 10. There are different types of scans that we can use using different stages of our pipeline. As part of the PR, we can use those GitHub actions. We can trigger software composition analysis, SCA, as well as SAST, static application security testing. So the SCA, that scans the software and the libraries that we're using. Software composition analysis scans those common libraries for known vulnerabilities. Something like Black Duck or Sneak will check our NuGet packages and npm packages, and it's looking for those known common vulnerabilities in the packages that we use. And it looks through those bill of materials and that dependency chain, and it just makes you aware of everything that you're bringing into your application just by using those libraries. So static application security testing, this is the code, and it scans the code that our developers write. Something like checkmarks or Veracode will scan our code from the OWASP top 10. And then we have dynamic application security testing, and this scans the code once it's deployed. Something like Burp Enterprise or Invicti, it will crawl our website looking for vulnerabilities. It can only scan the externally accessible environment running on a credential scan. So we need to allow it through the firewall if we want to purely test the application and not the network defenses. We can use something like Nessus to show us the security posture of our network infrastructure. So release management. We need to aggregate the results into the release management tool. This is so that we can see the risk profile and the security posture of the potential release candidate. The business can then make an informed decision based on the risk appetite for the deployment footprint. Attack surface management. This comes back to managing the blast radius in the area of change. We need to manage the attack surface and the threat landscape so that we can validate our security controls are effective. And then we need to list the prioritization. We want to shift left and run these security tests as early as possible to give fast feedback. As the results can come from multiple tools with different levels of severity, we need a list of prioritization. The different levels of severity will have different remediation timescales, different SLAs for resolving them. Any critical issue may be fixed immediately. Next priority is the high-risk vulnerabilities, but those moderates and lows, we can be more relaxed, and we can have a longer timescale because they might not necessarily need to be resolved right away. It all depends on those CVSS scores. So next, let's look at deployment. Does this need security? Yes, we need a secure delivery pipeline. So we need code signing. Deployment candidates should only come from a trusted build pipeline. Deployment packages can have a digital signature for authenticity with an integrity check to protect against modification. We can use a build server like Azure DevOps, TeamCity, or Jenkins to sign the code. The build tool should only have responsibility to compile the deployment candidates, and they can be versioned and archived so that we can keep track of the actual build output. The settings on the build server also need, and the shared build task groups also need to be audited. So secure deployment. Software deployment should only come through a trusted deployment channel. Trusted deployment tools should use service accounts with limited permissions. Access to the deployment target should be restricted. We can use things like Octopus Deploy or AWS Code Pipeline. It's good to separate out the act of compiling software and deploying to an environment. AWS Code Pipeline uses code build and then code deploy. We can plan a scheduled release, a rolling linear release or blue-green type deployment, and this needs to be strictly controlled depending on the criticality of the application. So a controlled release. Only our trusted deployment pipeline should have access to push a deployment candidate to our deployment target. Only trusted people should be able to turn on the feature flag to release that new functionality. We can require a requester and an approver with MFA before releasing any new functionality to live. This allows us to separate out the act of deploying versus the act of releasing that new functionality. We can deploy code to live, safe that it is not going to be executed as it's protected by a feature flag. The business can then maintain control over that new functionality and enable it when they want to based on their big bang release or their timescales. And that's how they control the delivery to the end users. Okay, so let's look at the next step, maintenance. Does this need security? Yep, we need security updates as part of ongoing maintenance. So once a feature has been deployed and released, it doesn't mean we're done. We can't just walk away and forget about it. But yes, we might move on to that next big project. But we also need to maintain our existing applications. So ongoing feature delivery. We need to build a feature-rich application with ongoing feature delivery. We will include ongoing iterative architecture reviews as we complete each project milestone. ongoing application maintenance. We need to allocate time in our project roadmaps to schedule maintenance. This should line up with our annual penetration test and the planned remediation work. Let's update some NuGet packages, some NPM libraries, and keep our application patched and up to date. And we want to do this proactively rather than reactively to known security vulnerabilities in common libraries. So next, security monitoring. We also need to keep an eye on the security monitoring. The Security Operations Center will be constantly monitoring our applications. They need to tie into the security information and event management system with log aggregation. We need alerting and incident response, reacting to triggers from event detection from our IDS and IPS. That's our intrusion detection system, intrusion prevention systems. And we should do all this with a security orchestration and automated response. So try and make it as automated as possible. We'd like to orchestrate and automate that corrective action to those repetitive tasks. We can use things like Dependabot and Renovate to automate our package updates. And this helps to keep us up to date with new packages as soon as they're available and offer new functionality alongside security updates. So business continuity planning. Even if nothing changes, new threats can be discovered. So we need incident management and incident response, and we can practice this through tabletop exercises. We need to regularly practice and review our business continuity management. We need a full disaster recovery simulation to periodically test and verify our business continuity plan. The aim is to identify and remove any single points of failure and verify our recovery capabilities should the worst happen. We can test our DIR capabilities and response times. We can verify our backups are secure using integrity checks, and they work as intended. Bringing it all together and ensure they're resilient against environmental disaster and ransomware attacks. Yes, backups need to be access controlled too, and also need to be resilient from ransomware. Test your recovery point objectives and make sure that you're protected against data loss. And we also need to pass those compliance checks. We also need compliance checks, and we want to automate internal auditing, and we want to build things like fitness functions. Things like AWS Control Tower and service control policies can act as an automated guardrail for ongoing development. Okay, so that brings us to the end of the different phases of the SDLC. Time to bring it all together with a quick recap. So during analysis, the business may discuss potential security concerns at a high level. Moving on to the design stage, the architects will formulate a secure design. Ready for development, the team will build the feature abiding by our secure coding standards. As we move into the testing phase, we need SCA scans for software composition analysis. We need SAST against our code and DAST against the deployment application. Ready for deployment, we can aggregate those security scan results into the release management tool of our final release candidate. And finally, we've deployed, we need that security updates and security monitoring as part of the ongoing maintenance to support our running applications. So the key takeaways again, analysis, security requirements, design, secure design, identify the digital assets and the access controls, authentication, authorization, and auditing. We need the development, the different stages of development. They need the secure coding standards, secure the APIs against the OWASP top 10, the OWASP API top 10. Make sure you've got adequate testing in place, the SCA, the SAST, and the DAST. And then deployment. Make sure that you're deploying in a safe, controlled manner, and make sure that you build in time for maintenance to keep things up to date as well. So I've covered a lot of things. So that encapsulates the secure SDLC at iPipeline in a nutshell. And as we wrap up, I want to reference some guidance material outlining the topics I've discussed. So we've got the SDLC with the security layered on. I want to touch on a lot of different topics and processes. We can try and track the effectiveness in a quantifiable way as we try and measure ourselves against the capability maturity model. Basically, we want to measure how well things are working across the organization and identify any areas of improvement to make things more secure and more effective. The topics I've discussed today track very closely to the ISO 27001 series for security guidance. ISO 27034 specifically details implementing security controls into the SDLC. There will always be some room for improvement and process maturity, but it's a good point to start. You've got to start somewhere, and then you can look for them for additional guidance. Another great reference point is the OWASP SAM, the software assurance maturity model. We can follow the OWASP software assurance maturity model for more information and best practices on how to improve the organization's security posture. And that covers the complete software lifecycle. So that concludes everything I wanted to talk about today. I hope you found that insightful. And are there any questions? How are we doing for time? Yeah. Okay.
So if anyone wants to ask any questions, can do. People online, you can either open your mics or type them in the chat, but we'll take some questions from in the room first.
Yeah.
Can you just repeat some of those tools you said you'd run on the PM?
So on the pull request, we would use GitHub Actions. So you write the code on your development branch, push the development branch. As soon as you open the PR, it runs the pull request, runs those GitHub Actions. So you can use Black Duck for the software composition analysis. So automatically trigger that Black Duck scan, that rapid scan, so you can see what libraries are being introduced. You can also run against your SAST tool like Checkmarks or Veracode. So as soon as a developer writes that code and pushes it, if they've got a PR open, they can just wait for those results straight away. So when it comes to the reviewer reviewing the code, first thing they're going to do, look at the JIRA item, look at the story, the requirements. Second, look at the pull request. Do those code checks pass? What's the security footprint from Black Duck, the new libraries introduced, check marks, the new code vulnerabilities. And you can set a threshold, and if they've introduced a new high, fails the build, fails that GitHub action. You can then accept it if you want to, if it's not a high or a false positive, you can up the threshold, and then once you're happy, you can then approve the pull request. Once the pull request is approved, it goes into master, and that's where you can run your more in-depth scan. Now, you might want to run a full scan there, and that might take half an hour to run, but you don't want the developer waiting for that feedback. You want them to just get that rapid feedback. So once it's in master, then you run the more in-depth scans. And the master scans, they might be running every hour, whereas the pull request scans, you might have 20 different pull requests open, lots of developers writing code, so you want that rapid feedback rather than filling up your system waiting for those scans. Yeah?
I was going to ask you, in the software development lifecycle, in your experience, are they all pretty equally difficult, or are there tricky sections that are trickier that end up being more problematic?
Yes, there's definitely problematic areas of code. So every company's got that one legacy system that nobody wants to talk about or acknowledge, and nobody knows how it works, nobody wants to touch it. And that's an issue because the older it is, it's got to be resilient against time, but you still need those updates, you still need that maintenance. But those legacy systems, sometimes they're legacy for a reason, and it's hit the end of its product life cycle. So it's massively expensive to rewrite, or it's overcomplicated, or it's picked up so much technical debt, it's just like a spaghetti ball of mess. So those systems, yes, they're going to have the Black Duck, the software composition analysis, they're going to use outdated libraries, but you can't replace those libraries because it's a break and change. The code scanning, yes, you're going to use check marks or Veracode, you're going to look at the code being used. It's going to pick up more and more kind of vulnerabilities the older that code becomes, and you're going to have to sort of break out modules to rewrite it to make it manageable. Or you just sort of try and abstract that away, make it like a more internal application and do that layered defense where you're just exposing functionality through more secure APIs to try and mitigate that risk. So yeah, legacy applications, hard to work with. The new front-end applications can be equally challenging because JavaScript frameworks, they move along so rapidly, it's hard to keep up to date. So things like ASP.NET and web forms, they're relatively stable. But stuff like Angular and React and Vue, they use lots of NPM packages, so lots of different libraries. So there's always new vulnerabilities in those libraries. So you're constantly updating those packages, which is more maintenance and overhead, and you've got to sort of plan that in, and it's more cost to working with those frameworks. It's just trying to get the business to understand that they've got to keep investing in those front-end applications more than those legacy back-end systems. Yeah.
that in the development, when there's something that someone has pushed, for example, they wrote a code, and someone has to approve that to make sure this is from the right person and it's not trying to sneak in any hurtful code.
Yeah.
Is there a way to flag them out automatically? You know, if there's someone impersonating someone in the team and is someone external and trying to push something, you know, that could hurt the system, how do you flag that out automatically?
Yeah, okay, so that's a good question. How do you make sure that you're making secure commits? So this comes into your internal tooling. So I've got Git installed on my machine, and we use GitHub secrets, and that will scan on my machine to see what I'm committing. So if I commit like an API key or a secret, it'll flag it up and it will stop me from making that commit to my local Git repository. I can't even push it. So you've got that security on your tooling on your local device. Once I've done my commit locally, my GitHub account is synced with my organization, it's synced with my browser, and I've got that session. I've got to log into GitHub with MFA before I can even push the code up. So you've got MFA on pushing into the private GitHub repository. Once it's in GitHub, it's just on a branch. Nobody can commit straight to master. You've got branch protection rules in place to say you've got to pass this branching policy. It's got to come from a pull request. So you've got a pull request template saying that you've got to fill in all these fields. Yes, I've ticked, I've tested it locally. Yes, there's unit tests. Yes, these tests pass. And you can't approve the pull request until the person submitting it has satisfied all those requirements. So if there's no unit test, test coverage goes down, pull request fails. Can't approve it. You've got to at least write one unit test to cover your code so the coverage stays the same. Then you've got to pass those security checks, and then you've got to pass the code quality review. And you can say it must be approved by a lead developer or requires 2 approvers. So somebody to propose a change, somebody to accept it, and then somebody say, fine, it's ready to merge. It depends how tightly you want to restrict stuff going into master. So if you've got a critical system that's worth lots to your company, you want to tightly control the code going into it. If it's a legacy system that's already picked up a lot of tech debt, you might be a lot more stringent on the kind of quality that you allow into that application. But those front-end websites, if it's just an MVP and you're just trying something out, yeah, just let it in. As long as somebody can review it and approve it, you probably might want to re-engineer it anyway. So yeah, depending on the type of application, you can be more strict or less strict as you need to be. But it's always going to go through that pull request and get approved by somebody that can trust it's been coming from a trusted source. Any other questions?
So
Yeah.
you mentioned about, I've seen before, especially with front end, we've got different software all the time, we've got different programming languages. How do you, as a programmer, manage or determine what are the best requirements and what consider, for instance, like some people still like PHP, but we know that PHP to be very vulnerable as a programming language. How do you, especially with JavaScript having so many new frameworks, it seems every week these days, how do you manage that and decide we're going to use this, or what is your base requirements, would you say?
Yeah, it's a very good question, and every company does it differently. So the business will say we need a new website, it's got to be offering this functionality. The development team might get excited and say, sure, let's use the latest framework. But the architect team will say, no, we're controlling the technologies that are approved in our ecosystem, in our tool chain. If you don't control it, you end up with one team writing in React and the team working in Vue. Backend code, maybe it's Java, maybe it's PHP, maybe it's C#, and there's a whole lot of complexity with managing all those different libraries, all those different technologies that you're using, and all the server overhead and whatever as well. So you've got to control it. So the architects will look at the roadmap in January. They'll decide what they want to achieve this year, and each application should have its strategy and its roadmap. So we've got this API. It's looking a little bit old. We should probably move it from .NET Framework to .NET 7. Well, let's wait till .NET 8 comes out. That's the roadmap for that. Next team that goes in there, we want them to try and migrate it. Yes, that project's going to have an overhead now because you're saying you've got this technical challenge. You're not just going to go in and do it, but next time the business wants to invest money into that project, the core requirement, you've got to maintain it, you're going to upgrade it. But you're keeping your tool chain and your technologies in a controlled way. So it becomes more of a challenge when it's a global company, because we've got offices in Canada and got offices in America, and we might do another acquisition of another company and they might have a more diverse tool chain. So we'll try and bring in consistency. So, okay, they've got a Java application, we have to let that lie, but wouldn't it be better if you wrote the next one in C#? Because we've got a whole load of NuGet packages and internal libraries that you can just use that will speed up your development. And all our developers can help you and we can throw more resource at it. So always try and go for consistency rather than diversity. Always trying to go for a controlled thing rather than experimenting with different technologies. It's easy to get carried away with the latest JavaScript framework, but you've got to consistently build a new technology. So set your code pattern, set consistency, go for that to reduce your technical debt and your overhead of managing those applications. That's what I'd recommend.
A question on the back of that is, so you've got all this upfront planning of what you're wanting to work with. How often does that have to change partway through the process where you decide actually we want to use this now because we're hitting too many roadblocks or whatever?
It's a good question. So how do we keep the technologies that we want to use in the roadmap? The roadmap's just a rough guide. There's no point mapping out 12 months worth of stuff because then you're more waterfall and things change. So you might want to look at it quarter by quarter. There's a rough plan for each application and the technology that it uses, but that plan can change and sometimes it does change. So we might use a lot of AngularJS, but now we want to migrate to the latest Angular. But that's only because Angular is the right thing to do at that time. If React and Vue overtake it and there's massive benefits, you might want to reassess that decision before you throw weight into that project. So is Angular still the right framework for us to use? It's good for us because our developers know Angular and they're very effective and efficient in that technology. They can speed code Angular, but if you wanted them to work in the latest MVC, Razor or Blazor type technology, there might be performance increases in the code, but now there's a performance hit in development time because they've got to learn that technology to keep up to date. But yeah, things like that, it will be a business decision and the R&D team will try and pitch that case to the business product owner to say, give me the time to rebuild it for these reasons. Give me the time to migrate it for these other reasons. And it all comes back to the cost and the benefit and whether it's worth it. And you've got to reevaluate that decision at the time rather than making the decision 12 months ago and still being bound to it.
Does that happen often or rarely in your experience?
Quite rarely. So I find that in financial services, they like to build it once and run it for years and years and years into the ground and never rewrite it, right? They want to get value for money out of it. But at some point, they have to understand that it's more expensive to try and maintain it than it is to just throw it away and start again. And when you do want to throw it away and start again, they still don't want to let go of it. So they just want to make it internal only and then put something nice and shiny on the top. So when that happens, invest in your APIs because your APIs, they don't care what front-end technology you're using. Those APIs should withstand the test of time. And if they don't, you can just make them internal and then protect them with other type stuff. It does happen occasionally though. So there will be times where you've run a project for 3 years and now you want to build a new functionality into it. And you've done your domain-driven design, you've designed your architecture and it's built to solve X problem, but that problem changes shape and now you're trying to solve Y problem and that pattern doesn't fit into your code. So you might go for things like a 3-tiered application, application tier, your business logic tier and your database tier, but then you might want to try and fit the CQRS pattern into that and it just doesn't fit at all. So you're trying to write a new application for that pattern to match better data access patterns and make it more performant. So sometimes performance and scalability does mean that you have to rewrite applications because your old style of doing it has just come to the end of its performance. You can only put so much more RAM into that rack server before it hits capacity issues, and then you need to re-architect the way that you're doing the application. But it's a good question, though. Occasionally it happens, and it's an expensive mistake to get wrong, isn't it? It's an expensive decision to get wrong.
So you spoke about infrastructure and the roles of networks will play within your software as well.
Yeah.
We've been told we see these sort of updates around the software-defined networking, i.e. programmable networks. How will that be incorporated more into what people consider general software, and how will that be? Because we've got to maintain this code, we've got to make sure there's no exploits, and we're not relying on built software from a Cisco or a Juniper, for instance. So how does that come into play with current infrastructure?
Yeah, so the technology landscape is changing. When I graduated from university, it was all data centers and it was all on-premise networks or office networks, and there was heavily the company owned their hardware and they paid it to host it in a data center. So they had to buy rack servers, they had to buy that physical network infrastructure, they have to send engineers to the data center. Or you own something like on rack space or fast host where you're paying for them to use their hardware, but you just install your operating systems on the top and the rest of it. But you've still got engineers building that infrastructure, whether it's physical hardware or just building the network with those operating systems. Now, that's expensive to maintain because servers get out of date and there's the capital expenditure, the operational expenditure, and it's expensive to rebuild your network every 3, 5, 10 years. Like I say, financial services, they want to buy it once and run it into the ground. So what we try and do is we try and, if we can move away from managing that ourselves and get a managed solution, then we can migrate stuff to AWS or the cloud, and now we don't have to maintain that hardware. But you can still have a network that you need to run. So you're still installing operating systems. But wouldn't it be great if you didn't have to manage that network either? So you could go completely serverless. So at the moment, we might have applications that run on Windows Server, but the direction of travel would be to throw it away and rebuild in a serverless technology so that there is no VPN, there is no virtual network in the cloud, there's no networking at all. So you don't have to worry about network access control and those network related vulnerabilities. That's somebody else's problem. All you'll care about then is your application running serverless. The performance benefits is that it scales easier because you can just scale up more Lambda functions or scale up your code when you need to, as you need to, pay for what you use. So there will always still be those legacy applications though that don't want to die, and you'll always need a Windows server to run it. So you will always have a network. So you do need that software-defined networking. So for that, we'll have things like Terraform or the AWS software development kit, these using the Angular CLI, the AWS CLI, sorry, and you'll write that code in TypeScript, and it's TypeScript that you're writing. You're defining your application load balancers, your EC2 instances, the resources that you need to spin up. So you run the script, deploys your infrastructure, deploys your code on it. You can test it then, and then you can tear all that down. So now you don't need that development environment or that test environment. You can just spin up, build what you want to, tear it down at the end. And yeah, you need to make sure that that code is also secure, but it's a different kind of code. It's not application code, it's infrastructure type code. So you need security scans that can test for those like Terraform vulnerabilities and those infrastructure type vulnerabilities. And it can get quite complicated, yeah. It's a very good question. The landscape is changing. We're trying to move away from data centers and move away from managing servers as much as possible. So we'd have like long-lived servers, and we're trying to move from cattle rather than pets. So you want ephemeral servers. So rather than having one server that's been running for years with your software on it, the server should be short-lived. So you have a server, you want to upgrade the server, you just build a new server. So you might have a server running Windows Server 2019 with your application on it, infrastructure as code, install a new virtual machine, Windows Server 2022, install your application on that and kill off that old server, just kill it. Like you don't need to do an in-place upgrade anymore. So short-lived infrastructure in a scripted way using things like Ansible playbooks, it makes it very easy to upgrade, very easy to maintain. And you haven't got engineers logging into systems trying to do an in-place upgrade which fails halfway through.
Do you have any experience with Modal? Heard of Modal?
Modal?
Yeah, it's a fairly new company in San Francisco. It's serverless technology. Basically, you deploy, get ephemeral servers, and it elastically scales, and you just write Python code.
No, I've not heard of that. I'll have to check that one out. Modal, is it? Okay. Yeah, it sounds quite good. Yeah.
I was just gonna ask you what, if you were experienced with it, what you knew about it, but yeah, no. I've been playing with it and it's pretty nice, just because of what you said, you abstract away all of the
Yeah.
orchestration and you just focus on the application.
Does it make it super easy, and would you recommend it? Is there a bit of a learning curve to
There's
it?
definitely a learning curve, but I think it's easier than trying to dive into some of those other solutions you mentioned.
Yeah, we like the AWS SDK, the software development kit, because it's TypeScript based, and TypeScript feels more native to us as web developers. So you can write your JavaScript to define your infrastructure, but there's still a bit of a learning curve knowing which resources you can create and how to create them in those best practices. But yeah, trying to get a developer to write Terraform, it's a bit of a steep learning curve, and an IT ops engineer might know that off the back of their hand, but not a developer.
Spinning up servers, etc., and then written them. What tools to audit the processes?
When spinning up the servers and then writing them. Okay, so how do we audit the process? Good question. So if it's AWS, we'll have things like CloudWatch, CloudTrail to audit the AWS CLI commands that are being used. So we'll know which developer is using which AWS CLI with their access token to create the infrastructure. We'll have auditing in the AWS account to know which developers are building which resources, and we can use things like Control Tower to control what they can and can't create. So if they want to go and spin up a massive server, which is going to kill lots of cost, we'll say, no, you're not allowed to do that. You're only allowed to use these services. So we can audit what they've done. When it comes to building the server themselves, so we'll try and use those Amazon machine images pre-installed. We'll try and use the CIS benchmarks and try and use their best practice virtual machines to try and get a head start. And you will have auditing tools that go and assess those virtual machines, things like CrowdStrike and AutoMox and I don't know, Exonius type systems, which will go and scan the machine and make sure that it's compliant against that zero trust framework that I talked about. Each server will have a security rating based on, does it have this installed, does it have that installed, needs to pass this benchmark, and they do a security assessment against it to make sure that things like SSL are disabled and it supports a minimum of TLS 1.2 and that type thing. And like I say, we've got the annual penetration test for the application, but we also have the annual network vulnerability assessments. They'll come in and do a network-based assessment as well, just to audit us that way. In terms of compliance, we don't really do much for the government, but we do process a lot of GDPR, PII, PHI type data. So in terms of auditing, yes, we're Cyber Essentials Plus certified, but we're not ISO certified yet, but we track closely to them. So the external auditors will come in and assess this annually as well. Does that help answer the question? We don't really have any of those ISO Cyber Essentials type auditing tools that enforce our infrastructure as code type pipelines. I guess we're just not there at that level of maturity yet.